Hello, this is Mark. We're going to do yet another RP2040 design. This one will be really quite simple. I'm shooting this for the ECEN 307 class for the spring semester of 2026. Today is December 26th of 25. Trying to get a jump on things. Okay, so I've also deleted the what they call the preferences file for KiCad. So what happens is, since I've deleted it, it will not remember that I've ever run KiCad. So here's my screen. Let me bring up the KiCad for the first time here, and it gives me this warning message: configure KiCad settings path, and it's like just set the default, and that'll be fine. Next up, we're running a KiCad 9.0.6. Would you automatically check for updates on startup? Yeah, we can have it check for us and all that. Next up, we need to name our project and pick where we're going to save it. I'm pretty picky about directory structures and stuff like that. So I want to say I want a new project. New project. So there's a little window right here, and we can click that. And it comes up with untitled KiCad _ pro. You know, okay, so we need a place to put it. And I'm really kind of picky about where I want to put things. And this is going to be an RP2040 for the spring of 26. And this is really going to be a simple design. So I'm going to actually call it RP2040 S26 simple. And in my directories, I've got a pretty standard way of keeping things. So this is actually in a spot where I know where I'll be able to find it later. And I'll do save. Okay, so now it has created these items here, and it's the Pro, which is kind of the settings for the whole systems. Then you've got the PC board, and then you've got the schematic. When you open up KiCad, always open the Pro file and then edit the schematic or layout from there. You're going to get yourself in trouble if you don't. So if we're going to start with the schematic, and I click the schematic, and again, we get this another configure global symbol library table, and it's going to be, I'm going to choose the copy default library table. It says recommended. So we're just going to do that. We're not going to do anything too fancy. So it creates this massive window that is way bigger than I need. And let me get this shrunk down here. And because I need to get it just so you can see everything. Okay, so this is the starting window of the whole thing, and we need to well, let's put a part on it. Let's go ahead and we're going to click this thing that looks like an op amp over here, and we get yet another global footprint label, configure global footprint library table, and again we're going to go with the recommended. And it says 22,470 items loaded. I'm sure that when we do some sort of software update, there'll probably be even more. First thing I want to do is put in the RP2040, and I can just say RP2040 in the search engine, and you can see MCU Raspberry Pi. There's our RP2040, and I can pick it. Now, I've got a Mac, so it runs a little bit different, and one of the things that they do is there's something called warp and center on zoom. I find it really irritating, but basically if I go into a spot and try to zoom in, it recenters my cursor and then does the zoom type thing. And I find that really irritating. So I'm going to make a couple of minor settings. So if I go into KiCad and I say settings, we've got all of this stuff here, mouse and touchpad. And this is the center and warp on cursor on zoom. That one just irritates me. If you like it, that's fine. It can work either way. Automatically pan while moving objects. I kind of like to use that. Again, that's yours. Things, you can adjust these later as you decide what you want to do. You can change some of the mouse things and how things work. And I'm going to pan left and right with horizontal movement because my mouse actually does left and right. And so I can say, okay. So now when I zoom, it zooms wherever I'm at, and I can use that to move around or do whatever I want to do. So I find that way more convenient. And then if I go up and down on my mouse, I get this. If I go left and right, I get that. So I can deal with that. Now, we also have to just think about, as we put parts on this board, they need a package when we actually go to put them on there. I mean, a resistor is not just a resistor. You've got to say what type of resistor it is. And because this is going to be the first board for a lot of you, and it's all on surface mount, we're going to stick with a rather larger package. We're going to use 0805s for most of the components. For those of you that are really brave and want to go something smaller, do that on your next board. On this one, we want to basically stay with the 0805s for resistors and stuff. And if we set these components and the packages all early, when we put on another resistor, we'll just copy it and make changes. That way we don't have to do packages, assign packages later, or it minimizes the effort required. So here's the basic processor. We're going to need some power and ground for this thing. And again, there's a little ground-like symbol here, and I can just click on that. And under power, we're going to have a 3.3 volt line. So I'm going to go ahead and stick one of these on here. And I'm just going to stick it. I know it goes above here somewhere. And the other one I'm going to need is a ground. And let's go down to here to ground. Let's see, ground. That one looks good. We'll use that one. And that's ground. And I know the ground's going to end up down here on the bottom. There's the ground right there. And I'm just going to put it down here because that's a good place for us. Now, the first several videos, I'm just going to put on the parts that we must have. And then at some point, we're going to go back and say, okay, this you must have. Everything else is optional. So, this is just getting us started in this particular case. Okay, so there's my power and my ground. What do we need? I've got some designs here that I've done in the past that I keep looking at, and I suggest that you go get the Raspberry Pi Pico schematic and take a look at that, because we're really kind of going to be matching that for a whole bunch of things. So we're going to need a resistor, and we're going to need some capacitors. And they're all going to be 0805 size packages. So we just need to find one of those to actually put on the board. So I can go back to this component thing, and let's hit the little X so I get everything listed. And we're going to be under devices. And I need a capacitor. There's a capacitor right there. No default footprint. Can I get it from here? Oh, yes, I can. So here's all of these footprints. And I'm going to just pick it right here, and that'll make it easy, because then when we duplicate it, it'll actually duplicate with us. And we're going to go for the capacitor SMD 0805_2012 metric. Okay, we're going to go for that one. So that'll actually set the size for us. And then we can say, okay. So here's a capacitor. We're going to use a bunch of these in various places. And I'm just gonna throw it up here because I know I need it eventually. It's going to be a couple of them up here. But I just need one for the moment. And I need a resistor. So I'm going to do the same thing. Under devices, I'm going to slide down here, and I'm going to put they're in alphabetical order. So let me just get a resistor. Q, there it is, R. Very simple resistor. Default footprint says none's picked. We're going to do the same thing. We're going to go for the 0805 metric. I'm not going to bother with the hand solder size. That makes it just a little bit bigger. That's not going to really help us anything. So we're just going to go for that. Let me say okay. And where does the resistor go? I know that there's one sticking on this run pad here. Now, as I'm putting things around, I can rotate this part while I'm moving it. I can just hit the R key, and the part rotates. So if I'd rather have it horizontal, I can just put it right there. Now, this resistor, in this case, I can look up. I've got a sheet here next to me that tells me where things, are typical. These values are fixed. You don't have to bother editing them. It's R1. It's going to stay with that, but the R needs to be an actual value. So I can put my cursor on it and then just hit the E key, and it lets me just edit it. This one's going to be a 10K. Now, also, that's quite a ways from the resistor. I can also put my cursor on it and hit the M key to say move it. And I can put the label really close to the resistor. And then this R1, I think it's way too far away. I'm going to put it down here. Now, we want this run line to go through the resistor and then to plus voltage. So I can just do that right now. So there's this line over here. I can click this, and then I can just feed this over to there. Now that's got to go to 3.3. Let me just move this thing. And I can move it someplace close. Yeah, let's go there. I like my plus voltages to stick up and everything. And also, as you notice, as I get my cursor really right on these circles, you can see that it goes from that cross to a pencil-like thing. That means it's going to draw a trace. So I don't even have to click anything else. I can just click on the circle and click there. You'll also notice that when I complete a trace that the circles vanish. If they don't vanish, you're not connected. Okay, so there's that. Let me just add a couple more traces. I know this V out, there's a regulator inside the processor itself, because as much as this thing seems to run at 3.3, it actually runs at 1.1. So there's an internal regulator that drops it down. So what I need to do is this V out goes to VDD. So this pin actually goes from here to there. And they also recommend putting a capacitor on that to ground, and they're putting a 10 microfarad. So to ground, and here's the cap. So let me just move this cap a little bit, and I'm going to move the labels on it also because I just like to do that. And then I can take this trace and I can come over here and bring it down to here. You'll notice it makes the dot for me. That's really important that it'll be there. Okay, and now this side has to go to ground. So I've already got a ground down here. Let me come over here. I want that one to stay there, but I want a copy of this. So if I put the cursor on it, and I do, on my machine, I'm doing Command D for duplicate. So that'll give me another grounds. And so I zoom out, go close to where I want it to be, zoom up, and put it here. I'll draw the trace so the circles go away. Now that excuse me. Now that G and D symbol is in a bad spot. So let me just hit the cursor on it and hit move. And you can see that I'm moving it. So I can just come over here and move it there, which is a much more aesthetically pleasing. The C1, I still think it's putting them too far away. Let me just move that clear over here. The C is going to be the value eventually. And I'm going to put it down here. But now when I put this cursor on here, I'm going to hit the E key again. And this is going to be a 10 microfarad. Okay, so now I can even move it a little bit closer here because I know it's going to be like that. So, okay, so there's, this part has to be, this all is required for you to do it exactly this way. You know, this is not optional at this point. Okay, so the other thing we have is, this is where the power comes into other parts of the processor and the 3.3 volt line. So I need 3 of these lines to connect straight in. So let me make a duplicate of this guy. Oh, I'm going to hit the escape key and cancel that back out. I'm going to move this down just a little bit, just because when I duplicate this now, it actually keeps it in that closer. Now I'm going to want this to go really pretty close to in line with that. So I'm going to run this one up to 3.3. And then I'm going to run, this is for the USB system, has a separate 3.3 volt line. And then the VREG in, that goes to the next one. Now this ADC AVDD is the power supply for the A to D converter. So what I want to do is I want that to be a little better filtered. So I'm going to take a resistor off of 3.3 volts, run it through and use a capacitor to knock out some of the higher frequency noises and put that on there. So what I'm going to do is I'm going to take a copy of this resistor. That's too much resistance. I'll fix that too. And I'm going to put it right there. And I'm going to take a trace from here to here. I'm going to put the cursor on here on that 10K and hit the E key, brings this back up. I want this to be 100 ohms, pretty low. The other side of this resistor needs to come down to here. Now, when I'm drawing this line up here, notice that there is no dot on this pin 43 coming up. There should not be a dot. That is where several students have gotten into trouble in the past, and if I don't catch it early, it doesn't happen that way. So now we need another filter cap, and again we used 10 mic again. So let me just copy this capacitor, duplicate, and I want that right here because I want it off of this 100 ohm resistor here. So if I do this, that'll get us where we want. I want the other side to ground. Now, if I draw lines all the way through things, it gets really messy, but you know, I could just duplicate this symbol here. And then I'm going to put, I'm going to move this down for a reason in a moment here. And I'm going to do this. Okay, the other thing we really want to do is we want to add a capacitor for the processor. We can do this a whole bunch of different ways. One is it ends up being between the 3.3 volts and the ground, but I tend to place it kind of where I want to put it on the final board because you need these are called bypass caps. And I want this to be up a little further. Let me just move, I want to move the whole label. Let me move this up a little bit. Let me redraw this to add it back in. And I want another 10 microfarad cap. Let me zoom out a little bit and zoom in over here. I want another one of these. But this time I want it to go from, I can't start a trace as easy there. I mean, I can, but it's trickier. If I go over this way, it just starts automatically. And I can just stick it in. And now this one, I can do it this way without really causing much confusion. So, okay, we've got the power system pretty much in place. Let's see where we at with time. We're at 18 minutes. Let's see. I try to keep these at less than 20. So this is not a bad place. So I'm going to just say save. So everything is so nothing gets lost. You don't want to really do more than about 20 minutes worth of work before you save everything anyway. And we'll take up with the second video after this point.